So, hello everyone. My name is Adrian Matoga. Forgive me, I will stay behind this column because I have some code to type, and forgive me if something explodes because it's all going live. So I'm going to briefly introduce a project I've been working on for a few months already, and it's about pipelines that process streams of data with the syntax similar to what we already know for ranges. And what's special about it is that you can freely mix push and pull styles thanks to fibers and some automatically inserted adapters, which means that it's also a bit easier to interface with existing libraries that process anything. So let's start with some simple example. Does anyone have any idea what this code does? So it's basically what zcat does, or gunzip-c, which decompresses the zipped file into the standard output. If we compile that, it will do the same thing as the zcat does, apparently in similar time. You can also use input ranges and built-in arrays as source pipes, or you can use pipes as input ranges. So in the first case, this one will be special because actually byline returns the slices of the original array. So it's optimization that actually comes for free. You can see how it's implemented in the GitHub repository. Of course, it does what it's expected to. It just iterates over the sliced array. The next thing is that you can also use the pipelines as output ranges. You can do it in two ways. So you can instantiate an object that behaves like output range, and you can do put into it. You can also use it in more like left to right or top to bottom linear fashion. So you pass a lambda, and the actual source is at the beginning of the pipe. So that's a bit more convenient. And you can see that it actually written what we expected it to do. The next thing that you can, next thing that you can do is you can insert some optimizations for very cheap cost. So assume we have this CSV file. It's quite complex. We actually want it to extract just 3 columns of that and print it like tabular fashion. The code for that is like this. So first we inflate this CSV file because it's zip compressed. Then we iterate over it by line, and then just process it like any other range. The thing is that, yes, so it takes some time to process it, and we can do it faster if we just do these things in parallel. Now it's a bit faster. And the last thing that I'm going to show is that there are already some pipes that support some multimedia. I don't know if you will hear it, but there should be some music playing now. One special thing about this example is that you do not explicitly set audio parameters here, because the MP3 decoder here passes them as metadata to ALSA player, so it automatically knows what's the sample rate and bit resolution. And how it's done is also has this annotation. There is some underlying code that just inserts the appropriate calls so that it's able to actually read the value of these tags and get the notification that they changed. And this is how the MP3 decoder sets them. So that's it. Thank you. I know that there are some people that also work on streams, for example, Steven, and I took some inspiration, so thanks for that. I think that my implementation of inflate is a bit shorter. Yeah?
One question, is it cross-platform?
Excuse me?
Is it cross-platform?
Currently, I test it only on Linux, but I intend to port it to every platform that decompilers support. Any other questions? So, thank you.
Okay, my name is Attila. I'm going to talk about how we can have better unit testing in D. You are looking at text mode Emacs because I'm SSHing from this Mac into my laptop because you don't want to know. Anyway, right, these unit tests are awesome. Why? They are simple, and they are built in, which means you have no excuse to not write them. If you're writing a script that's 50 lines long, write unit tests, or you should feel bad about yourself, your life, and anything else that may come to mind. Anyway, they're great. But they're not super great. And why is that? Because, well, first of all, they run serially, and it turns out that we've had multiple cores in our CPUs for quite a while now. So they would be great if we could use that. Secondly, unit tests don't have names, which doesn't seem to be much of a problem because the default test runner doesn't really let you do anything with the names if they had them anyway. Which leads me to the next problem, which is unit tests are run all or nothing. Either you run all of them or you don't, and if they take forever, well, sucks to be you. Assertion failures are great when they don't happen, because if your tests work, fantastic, everything works. When an assert fails, good luck debugging that. And also note advanced features that I would like to see in a unit testing framework. So, fantastic that they're simple and you don't need to opt in, they're just there, you can just use them, but there are some things that which are not entirely great, in my opinion. Anyway, I came up with this very, very small, silly example of a project. It's a dub project, so I'm just going to talk about how you can very easily opt into a better unit testing experience if you happen to be using dub. So that's the main function. It doesn't really do anything. The dub.json for this project is this thing here. It's small. There's some stuff with triple underscores there. That's basically me commenting them out because it's JSON. And it doesn't really do anything. It just builds. And because dub knows how to test things, because it's a D project, you can just say dub test and things will work. So if I do this, it tests it and runs hello world because that's what my main function does, okay? Fantastic, great. Now, let's look at some of these tests. Very simple, function that multiplies by 2. There's an assert there with the usual stuff, and another function that does append, another assert there. Obviously, these asserts didn't fire or fail for that matter because we're not doing anything weird. And now I need to learn how to use this Mac keyboard. If I change this and go back to my shell and run dub test again, that should fail, right? But I get that. That's not great. Stack trace, no idea why it failed. I don't know. OK, so can we do better than that? Yes, we can. So let's, yeah, I'm aware. So let's change this. Let's go back to my dub.json file, and if I keep not typing things wrong. And let's go to my triple underscores, and let's get rid of them. I'm sorry, there's no better way of doing this, but I just wrote this. So that's the one, second one, oops, and it's third. All right. So literally the only thing here is there's 2 lines that you really need, well, 3. The dependencies, you got to use this library called unit-threaded that I happen to write. There's another line doing a pre-build command, so you generate a file that's needed. And then the main source file is just to tell it which one has the new main function. But if you add these 3 things to your dub.json in the unit test configuration, that's all you need to do. And the test we saw before will still be run, but it will look slightly different. Because I didn't test the guy. But at least I get a unit test failure, and I get some output that tells me what's going on. Those are the names of the tests. So the name of the module is usual, and the test just got named unit test 0 and 1. They're run out of order because they've been run in different threads, and you get an output that's slightly better. Now, I thought I'd fix my test, but apparently I haven't. Maybe I didn't save it. So save it, go back. Let's do that again. But this is already better, I think, right? Okay, I just opted in. I didn't do anything. Those tests that you just saw are exactly the same as they were before. There's no weirdness here. It's literally decode. There's not even any imports. All I did was assert. Now, why is this good? Because let's say I do want to start naming my test. So let's do that, if I can find out where at is on this computer. Nope, that didn't work. There you go. And now quotes. And if I run it again, just without not doing anything, that name of that unit test changed to foobar, right? So, thank you. If I want to run only that test, I can do this. 1 test run, nothing else. So what this allows you to do is select which test you want to run, and if you give it the name of a package, because we have a good package and module system, it will run all of the tests and all of the modules in that package and sub-packages. You can also give multiple command line arguments, so you run this test and this test, or this package and this package, and there's a bunch of other things you can do with this as well. But that's just the opt-in from not doing anything and not using any different syntax, or there wasn't even an import in that file, right? So we can do better than that, though, obviously.
Attila, can you do a regex?
Sorry?
Can you do a regex for filtering?
I couldn't hear that.
Regex.
No.
You don't want to hear it.
But I don't think we need them because of the package and module system. Also, I'm not going to talk about it today. There's a tag system, so you could use that instead. You can tag different tests and say, run everything with this tag.
Thanks.
If you have cross-cutting concerns, which will probably happen. OK. Now, I have a bunch of stuff here that's commented out, because or else it wouldn't compile, because, again, I didn't have a lot of time to prepare this in. I'm not even going to try to jump to the bottom of this file with this computer. I don't know what happened. OK, what can I do? What can I do? Page up doesn't work. Does anybody who knows a Mac come up here and help me with my Emacs? Yeah. How do I do Alt-Shift-5? Wait, this can work. Nope, that did not work. I know, but I'm trying to do this.
Try command instead of alt.
OK. Command instead of alt. Got it. All right, that might work. Maybe? Nope, no, it does not. OK. So I'm just going to do this by hand, because it's clearly going to take less time, and none of these things are that long, so there you go. This is awesome. It really isn't. Don't do this at home, kids, unless you want to lose street cred, which I'm guessing you don't have a lot of since you're at DConf. All right. That works now. So if I can go up to the top, I want to emphasize the opt-in nature of all of this. So here's similar kind of thing. If I can go back to one window. Yeah, there you go. Times 2 again, except this time it returns a range. Now, normally you'd write that unit test there in the bottom, times 2 with equal. Why'd you have to use equal? Because it's a range. You can't just assert equals, which is annoying, but there it is. I'm not going to run it or show it, because you just believe me that it works, and if it doesn't, you'll see it the next time I run the test. And for some reason, control stopped working. I think I lost focus. All right, I can't do anything. Seriously, I can't type anything. Oh, great. Right. Please come back. Right. Woohoo! You couldn't write this if you tried. All right. Let's go back to the thing, and let's at least make sure that this runs before I get embarrassed. Yay, there you go. Bunch of tests run. Now, let's go take a look at them. So this is the better stuff. You could use equal, or what you could do is run this thing instead. So here's where the opt-in starts getting more interesting, because you do have to import the library now, but you can do it in a version block so it doesn't affect your production code. And that's all you have to do. Now, because there's no special UDA, it's just a string, I can still name that test. I can put spaces in it if I want, or not. I mean, use your own naming convention. That means you'd have to use quote to the shell to be able to select it. But if you don't like doing that, don't put space in the name. It's up to you. But now I can just write 135.times2 should equal 2610. And the beauty of this is, of course, that I get better output. Because as you just saw, that worked. But what if I replace this with 11, say? What happens next? You'll never guess. And then I get that instead, right? Instead of an assert fail and a stack trace, I get that. I got what I expected, what I wanted to get, et cetera, a lot easier to debug. But there's more. So let's put this guy back to where he was. Let's go down. So there should be in as well. This is really useful if you have a range of some sort. Oh, and again, this works with ranges, right? There's nothing weird about that. That thing returns a map result, and I'm just doing 135 times 2 should equal array. Done. 6 should be in that thing. That works because 3 times 2 is 6. If it isn't, you'll see an output like that as well. So there's a few of these custom assertions that help with expressivity. And if they fail, you get a nice error message out of it. Or if you don't, then I've made a mistake, and you should file a bug. There's a few UDAs that you do need to import, and so the technique I would advise to use if you do use this library is to just version unit test it out, and then just declare something that compiles, just type checks, it doesn't really matter. In the case of should fail, there's just a struct with a string there, and here we have a unit test I expect to fail, and it does. As you can see, it's asserting that 1 equals 2. And if it doesn't fail, you get a test error at the end. Now, this is useful for when you have a bug, and you don't want to sweep it under the carpet, because it might unexpectedly start passing, so it would fail the test suite. And the reason why you can pass a string to it is so you can have a bug ID, and, you know, what reason did you tag this or should fail. And one of the things is that I'm going to finish up with, because I think probably running out of time, is, one really cool one as well is same set as. So iota 5, numbers from 0 to 4, should be the same set as 2, 3, 4, 1, 0, because I don't care about the order, and sometimes you don't want flaky tests just because things come out of order and you really don't care, so this is useful. But one really cool thing is parameterized tests. Sometimes you want to run the same test code with more than one value. You could do a for loop, but then you're back in the situation of a raw assert. Which one of them failed? I don't know. You just get something that failed here. The line won't even tell you anything because you're looping. That's not good. So if you use the values UDA, you can put any values you want. That's a template. In this case, I'm using strings, but it could be integers. It could be a custom type, a custom struct. It doesn't matter, as long as they're all the same. And I've annotated this unit test with this values thing, and now it's going to get run once for each one of those values in there. So since most of them don't have that much in common, here I'm just asserting that the length should equal 3. And there's no other way but a kind of icky global state thing in which you have to get the value and tell the type. But unit test blocks don't take parameters. If they did, I would have done it differently. There's another way you can do this too with a test function, and then it will know the type from the parameters it has. So in this case, of course, you saw the test passing, but what happens if I change 3 to 4? Back to my shell, and dub test. And you get that. Expected 4 got 3, and notice that foo is in the name of the test, because that's the value we passed to it. And there you go. Or I could have changed, instead of the, well, because both of them will fail, right? Instead of changing this, I could have changed just the value instead. Let's have a pirate bar. Bar. And only that guy failed, right? And again, the name's in the name of the test. Which means, of course, that if by chance this suite takes a long time, you can rerun just that one test with just that one value. Or not. Pass in, you know, lop off one of the dots, and you run all of the tests in that package. Go up one level, do whatever you want, go crazy. And you can also run them in one thread if you really need to, but by default it runs in threads, which I think is a good idea, because if your tests fail because they're running in threads, that's probably because your code is bad. So that's me. Thanks.
And I haven't even started. My name is Shemesh. I work for Weka, which is a storage company located in Israel in stealth mode, so I can't tell you what we're doing, but it has something to do with hard disks. Liran will give a more full lecture tomorrow, and he also gave a lecture last year in which he told about what Weka is doing with D, and also told about some of the challenges we're facing. And he finished off with a sentence saying, but you know, we love the language, our engineers are happy with it, most of them, because you can't please everybody. So, hello, I'm everybody. And this is the lightning talk version. I intended to give a full scale version of this talk, and we didn't have time in the schedule. So I'll start off with talking about the thing that bothers me on a daily basis when working with D, and that's the integer promotion rules. This is actual code. Whenever I'm showing actual code from the Weka code base, I'm giving the actual file from which this is taken. So we have two entities there that we're adding. We're taking parity start, which is an enum of type ubyte, and we're adding to it I, which is an integer of type ubyte, and we're putting that in disk index, which is a variable of type ubyte. And we have to put the cast there. And the reason we have to put the cast there is because D made two very, very reasonable design decisions. And each of them is very reasonable. One is to say that any legal C expression that compiles in D has the exact same semantics. And when you add two integers of smaller scale in C, you get an int. So the type of parity start plus I is int because of that design decision. And the other design decision, which is also very reasonable, is that D will not do implicit narrowing casts. So this is an int, and you try to put it into a ubyte without a cast. No, D won't do that. And the result is that our code is littered with those casts. And they're annoying. They're very verbatim, because the semantics for cast is you have one parenthesis for the type, and then it has a very high precedence. So it binds very tightly to the parity start. So you have to have the other parenthesis as well in order for it to actually take in the entire expression. And this is really a random example. I could take tens of others. And it really is annoying, and it makes the code less readable. And it also, I really hate casts when I don't really have to put them in, because one of the things that the decasts do is there's no way for me to say what I meant to do here. So if that wasn't an int, if that was a long, or if that was a pointer not really, but the thing is I'm not validating what's inside the parentheses. I'm kind. There is two, but the from is implicit by the type. The question was, Phobos has a to function.
I believe there's a cast function in Phobos that allows you to specify.
Well, maybe you're right, I don't know. But even if that's true, that would make this even more verbose.
Yeah, it's in the std-conf, there is a cast from template where you can specify the from type explicitly.
Okay, so got that off my chest. The other thing that really, really bothers me is something which I think a lot of you will disagree with, the title that says, D does not support RI. Bribe is resource allocation is initialization. It's a methodology that C++ promotes really heavily that says we're never allowing resources to be left dangling. Whenever we allocate a resource, be it memory or a file or whatever, we immediately wrap it in a handler, which is a C++ class that has a destructor that is in charge of releasing that resource. And by doing that, we make sure that we're not leaking, that we're not forgetting something. And the official line is that D supports RI because you can do a struct. The struct has deterministic destructor. And when that destructor runs, you can make sure that the resource is released. The problem is that destructor isn't 100% guaranteed to run. And this is one example. The QR code is a link to the forum where this is discussed from about 2 months ago. One of the things in that discussion is a pull request trying to fix this problem from, I think, 2012. And the thing is with RI, just so you understand the code, this is part, the link actually has the entire program. What you're seeing here is a RI struct as a member of a different struct. The different struct initializes the RI and then throws. And what happens is that the RI gets initialized, it gets the resource, but its destructor isn't being run. Again, because of a conflict between the definitions of how a constructor is built. And the moment that happens is that we leak. And the thing is, if you're trying to use RI for peace of mind, then you can't have any leaks no matter what.
A comment on that is a bug in the compiler. It's not a bug in the language.
Okay.
And the second thing is, although a lot of people disagree with me, I'm a strong proponent that constructors should never throw. But there's probably a lot of existing code that does that, and I can't
we can
fix
open that
now.
discussion, but then I won't fit into my 5 minutes time slot, so.
Okay.
Or the entire day. Which is not to say that I wouldn't love to have this discussion with you, by the way. One more thing that bothers me when trying to raise those issues is kind of the reply I'm very often getting from the community, from the forum, which says something like this. You go and say, okay, there's a construct that I'm used to using in, say, C++. D doesn't have it. And people say, well, you know, this construct is mostly used to do this, and D has a better way of doing this, so we don't need the construct. And this is a bit of a controversial example, because Liran and I don't quite agree on how much it represents the problem that I'm saying. But this, again, is actual code from the Weka code base. And you really don't need to read anything beyond the name of the file in which it exists. The specific example, Weka is automatically wrapping functions with a tracer. So whenever you write a function, merely calling it gives a log that says, we entered the function, we exit the function, these were the parameters and coming in, this was the return value. And in order to do that efficiently, each function gets unique identifier, which is an integer. And this integer is stored in the read-only section, and the integer is filled in. Since you can't do modification in Ctfa, this integer is filled in by a post processor for the binary, which leaves us with a problem, because what it means is that the function entry now has code that defines an integer, a const integer, and then uses its value. And the compiler says, well, I don't need to read the value from memory. I already know what the value is. I just initialized it, and it's a const. The thing is, you do need to know, because it's not going to end up with the same value it has right now, because during Ctfa, we don't know what the value is going to be. And in C++, we would have solved it quite simply. We would put on this constant, we would put a modifier saying volatile. But volatile is used to read from register memory, of memory mapped registers from hardware. And D has a better way for reading from memory mapped registers from the hardware. Volatile is used in order to implement weight-free algorithms. D has shared. It's already taken care of the memory barriers, so D doesn't need volatile. But we do. So what I'm trying to push here is to say, be more open to use cases that are not what you would expect. So maybe yes, we have good solutions to what this construct is usually used for, but maybe not for all of the use cases. This is the last one I'm going to talk to in the lightning talk. There are other things I would love to talk about. And that's a bit of a confusing syntax. And when I say confusing syntax, I mean that you've got a syntax element that usually means one thing, except in a certain case where it means something else. So parentheses were not used for function calls, are used for grouping. I've got a bunch of operators or a bunch of elements, and I'm grouping them so that they be guaranteed to be evaluated together. When used like that, any parentheses that surround a single element are automatically redundant. They don't do anything, because it's a single element. You can't split it anyway. Except, and using that logic, you'd assume that array 2 would have the same type as array 1. Except that's not the case in D. In D, array 3 has the same type as array 1. Array 1 and array 3, in case you're not sure what it means, mean a const array of const characters. Well, array 2 means a mutable array of const characters.
Way to think about that, and this has come up many times, is if there's no parenthesis after the const, it applies to the declaration, not the type. And the parentheses means it's applying to the type inside the parentheses. So that's why the rule is the way it is. So if you think about it that way, const with nothing after it is applying to whatever the type of array 1 is, as in total, as opposed to some part of it like you would, like what the parentheses gives you.
Then again, I'd expect to say, okay, so let's treat const as a really low precedence modifier, and say if you want to do option number 2, may have the parentheses surround the const and the char, except that violates the way definitions look. But that would be more intuitive than this, which is very confusing, and it's not the only example. If you take, for example, curly brackets that are always opening a new scope for definition, except if they're part of a static if or a version, in which case they don't. The variables defined inside curly braces as part of a static if are part of the surrounding scope. And I have places where I have static if and 2 sets of curly braces, one for the static if and one for opening a scope because I actually need it. And again, it's a construct that usually means one thing, except occasionally another.
Do you know how to remove a brace?
I understand why
Anna's
that...
question. Anna,
No, I do.
It's for real. You can't remove a brace, but you can insert one. So, let me preface this by saying C++ has that same thing. Array literals and enums use braces to not introduce scopes, famously. So that's one thing, because you introduce like C++ lover, right? So it's the case in C++ today. And second thing, I think static if is next to useless without the braces, and mightily useful without. So essentially, it's a very easy to justify design decision. I understand how this can hurt one's sense of sensibility, but it's just a good language engineering, in my opinion.
Okay, I understand. I actually do understand the causes, the reason why that's defined this way. I'm saying it's confusing on a daily level, which is, to me, I think, is a bit of a problem. Things I'd love to have time to talk about, but I won't, are undefined behavior, which, in my humble opinion, I think in D is present but unaddressed. Cross-feature complexity, where you have one feature and you pretty much understand what it does, and you have another feature and you pretty much understand what it does, but then they sort of merged, or you try to use them together, or you don't realize it and you try to use them together, and really unexpected things happen. The lack of a ref type. The word ref, when you add it to a type, does not turn into part of the type. It is a modifier for the parameter to a function or a return type. Const, which I know it's a subject that comes up occasionally, but which I think, to me, the undeniable and without exception transitivity cause it to be much less useful than it could have been. The problem with complex CTFEs, with complex functions that happen at compile time and debugging them or even understanding what they're doing. And, well, nothing anyone here can really do about the last one, but it is a pain point. So I'm done. Thank you.
I mentioned when I was doing my talk that I cut a couple of slides. This is just actually going to show these slides because I figured it was perfect for a flash talk format, and I've lost the play button. Where's the play button on this thing? It was there, but now it's on the edge of the window and it's gone. Sorry, it's in German. I don't really do German. All right. So basically, there's this really simple, we see it everywhere in the video game industry, piece of C++ code that I found that really shows off what I consider to be the insanity of C++'s template, specifically template specialization system. And that's this little interpolation function we've got here. Can you all see the code this time? Is this legible? Oh, come on, get some binoculars. You're all the way up there. All right, so most people can see it, right? Okay, this is a function as it exists in our math library. It's an interpolation function. You give it two values. They're usually floats in our code base. And it just interpolates with a percentage from one value to the other. Pretty simple. But to my eye, that looks weird. And that's simply that part where it does the multiply by a 1 minus the ratio. That, to my mind, is an unnecessary multiplication. In video games, we abuse the floating point processes is probably the best way to say it. So any kind of reduction of what you see as unnecessary floating point options is generally a good thing for your performance. The form of the function that I would expect it to look is down below. For floats, it gives you the same values, possibly a tiny little bit more accurate because you're not doing two multiplies depending on the values you're dealing with. So whether the above one would have 1 subtract 1 minus and 2 multiplies, the bottom one would have 1 subtract 1 minus and 1 multiply. And I thought, okay, that's great. That's going to help very slightly. Make no mistake, that is the definition of a micro-optimization. And then it was pointed out to me by one of our other programmers that it was a buggy function. And what that ended up being because of is another fairly standard thing you'll see in the video games industry. It's a little class here representing a color. It has unsigned characters for each of the red, green, blue, and alpha components. It has some operators on it so that you can use standard mathematical functions for it. And the problem specifically with the single multiply form of the interpolation was that when you give it unsigned values and you interpolate from a higher to a lower value, the integer wraparound happens on the minus and it gives you a completely wrong result. Now, I wasn't particularly happy when I found that, but I was like, well, there has to be a solution here in C++ code. Maybe with a bit of template magic, I can just get in there. We get a little struct there with static methods inside it that you specialize. There's a bool up there, B is signed. The original function you'd call lerp would have a wrapper into B is signed with the types you were using and a call to standard is signed for the value result from that. And that seemed all well and good. The only problem there is that then means you need to specialize standard is signed for each and every single type that you're ever going to put into this function to give you the correct results, which basically makes it an unmaintainable, buggy mess. So at that point, I admitted defeat. C++, you have won. Your rubbish systems have resulted in going back to the original code with 2 multiplies. Compared to the D functionality. Like we have the both forms of the functions there. The bottom one is the way I would expect to do it. We've just got a little constraint down there to make sure we're passing in a floating point for the ratio function. And then up the top, we've got the 2 multiply form that does type inspection on the type you pass into it. If it's a basic type, that's easy. That's in the standard library. If it's a more complex type, it'll pass over it. It's a pretty similar way to what we do in the auto-serialization code I was talking about earlier. Work out whether any of the types inside there or any of the subtypes inside there are unsigned. And it would just work. This is a function that no longer needs maintenance, will give you the best result for floating point behavior, and will just handle any type you can throw at it, basically. And this in particular, something very simple like this, is something that I think can be used quite effectively to get other game developers on board for the language. Like the maintenance hell you go into for doing the same code as C++ for something as simple as that is just insane. When the answer to the problem is right there, use a different language. That's it.
Okay. Hello, I'm Stefan Koch. And I'm 24 years old. I've been curious about programming since about 7. And 2012, I discovered the D programming language. Actually, I think it was in a foreword on a book of programming for children, and they made a joke. Yeah, there was this language called C, and then came another guy called B, and he made a language called C++, and then came another guy called W, and he made a language called D. And suddenly, I don't know why, I woke up and I surfed on the internet, and I suddenly remembered that I read that there was this language D somewhere, and I wanted to check it out. So I went on the website and downloaded the compiler, and yeah, there weren't much tutorials for it. So the next thing I did was to order Andre's book. So I would say my first 5 minutes with D were actually reading Andre's book, and I think those were very great 5 minutes. And I read the rest of the book in like 2 hours. And it was a very entertaining read, and I learned a beautiful language. And this language can do stuff like, why can't I? Am I already in the directory? Yes, I'm already in the directory. Do I have dub? No, I don't have dub. Okay, then I have to type the compile command manually. So first, do I at least have nano so you can see the source? There's this test file. It's called void static unit test. It has this, can everyone read this, or how do I make the command plus? I don't think it works. No. Can you help?
Make it bigger?
Yeah.
This?
Yeah, and here's another font. Oh, yeah. So everyone can see this is a static immutable U-bit array. And if you know a bit about ASCII, you'll see that in here are not many ASCII characters. There are few one recognizes, but the first ones are not ASCII characters. Actually, those 4 bytes are the magic header used by LZ4. And LZ4 is a compression algorithm that is widely used in stuff that has to be fast. And I just implemented it because it was simple to implement and it was pretty fun. So let's, you all see this static assert here. So this program should not compile, because how would you decode that file at compile time? The static assert will fire. So, whoops, no, I don't want to. So I do dmd dash source test dot d, and I press enter, and okay, that is okay. I did not expect that. So yeah. What he's doing, he downloads the
dash?
the build script.
What's the dash? Damn it. Do you know where the vertical dash is?
What he is doing, he is downloading the installation
So we
script
need an OS X specialist somewhere.
from the site.
What?
Just do wget on it and then execute it with
Yeah, okay. Yeah,
with .sh. This is how you should do it anyway. You shouldn't just execute
it's fine.
stuff.
You can do that.
Yeah, you wrote it, right?
Yeah.
Yeah. So.
Oh, it doesn't even have SFX. It's amazing. It's a completely unequipped compiler.
Why don't you just copy that link?
Because I don't know how. Where's that? Wow. Did that work almost?
I don't think so.
It should have. Well, okay.
Okay,
I
so.
almost give up.
So, since you all know D, I can just show you the.
Yeah, that's no longer the problem.
Since you all know D, I could just show you the code from the.
Okay, we'll give up.
I can just show you the code that I was going to have tested, and because you all know the LZ for algorithm, you will know that it is correct, right? So one thing you need at Ctfa when you want to work with binary formats, at Ctfa you just get. Where is the function that it's further down? You just get this. You just get this const U-bit array. Actually, it's a const car array. You have to cast it to make it into a U-bit array, and that's all you get. You can't do pointer cast. You can't take the pointer from the array at your offset to it and then cast that into an integer. So what you do is this. You have this template that gets instantiated with this type. This type has a size of. This for each is static because it is used on static values, so it will evaluate at compile time. In this static if, I'm just provisioning for if I ever want to use big endian, then I will at least know that this breaks by the endianness here. So I won't look at corrupted data and have no idea what is going on. I can just change the endianness if I should feel it is necessary, and this static if will, it's basically like hash if in C, so just this code here will get compiled and it will all get optimized, so it will just do a shifts to make sure that the U-byte array that I passed in is read as the type that I have, and I didn't want to import phobos, so I just made this poor man's is integral here. I just check if the type I'm converting here is implicitly convertible to long, which applies to every integral type. I'm not sure if it applies to characters. It should not apply to characters. I think it just applies to integrals here, and then here in this constructor, I'm taking the same array and I'm just checking that it is actually a valid Assert for header. And here we do the decode the decoding of the Z4. It works at Ctfe, and it works quite efficiently if we did not have this. This is, you should, when you see this tilde character, it usually means slow. because you usually use it on arrays, and array concatenation is not fast. I found out that when I reserve the capacity beforehand, it gets even slower. I have no idea why. Probably because it has to do a bunch of runtime calls that can't be elided when it gets the length and tries to update it. And you can't call reserve at Ctfe. So if I were to reserve this, I would have to put an if not underscore underscore Ctfe in here, and then I could reserve it. Anyway, it would most likely make this slower. But what I really like about D is that I can put those static asserts and static unit tests everywhere, and if it fails, I will not even have an executable that I could accidentally ship. Of course, when I don't have D and B on the machine, I will also not have an executable that I could accidentally ship. So, yeah, now I can't show the very, very cool Ctfe compile time. It is basically a parser that works at compile time, then it goes through a transformation pass that converts the input language into D and then mixes that in and makes your functions that you have written in this language available in your global scope, so you can just call them. And this is pretty neat when you want to translate from different languages into D and you want to integrate it with your compile time workflow. It will just work. You can even evaluate those functions at Ctfe because they get translated to just normal D code, and you can do this with almost anything. I did have a prototype that didn't work that would take those how they call those preprocessor directives and would turn them into for example, turn the preprocessor directive if underscore 132, it would turn it into version Windows, and then it would set an immutable bool when 32 to true, and then it would check it in a static if. And the reason why I do that and I don't just use version is because I translate relatively stupidly, and I just check if I have used the version the first time, then I will not emit the version, but I will check in static if, and so I can rebuild the C preprocessor stuff in D and have it just work. And this would really have been so much more awesome if I could have shown you the code that works and simply translates a C header file, like simple C99 header file, because I really don't want to mess with the C++ at this stage, and I certainly don't want to parse it at Ctfe because I'm already having problems with too much memory consumption at Ctfe when you work on very low-end machines. For example, your 2-year-old Android phone, then you have a problem with that. So what I want to say about D is, for me as a, well, when I was a newcomer to D, it was a great language, and now that I have discovered all those possibilities with templates and Ctfa, it is an even better language. D is really awesome. Finish.
Stefan, two questions while you switch the laptops. Number one is, what other ideas do you have for using? So apparently you caught quite some fluency with compile time execution of arbitrary code, which is awesome. And the question is, what other ideas do you have for applying that that knowledge that you earned? And the second question is, what is the sort of the worst? What should we put on the front burner to improve Ctfa, which is a strategic feature of D?
First, to improve Ctfa, well, I talked with Walter a bit about the whole problem, and the thing is, Ctfa is really a hack. You can see that it's a hack. It's implemented as a hack. It is the most useful hack that I have ever seen, and it is definitely a hacker's tool to do stuff that are like magic. But to be fast, it would need to be heavily redesigned, re-implemented, possibly executed in multiple threads, because it is used for stuff that we could never have envisioned when it was invented. Like, it was more like this accidental thing. Yeah, you have this mix-in, and you can do stuff with strings, and this feature, Ctfa, just turned out to be so useful and so heavily used, which was probably never anticipated. So what should be made better about Ctfa is all of it. We need to re-implement it properly, and then it will be really great. And what I see for other things you could do at Ctfa, well, at Ctfa you can do everything that does not depend on the state of your system. At Ctfa you can do anything. Every data you can somehow beat into the compiler. You can work with it at Ctfa. You can do this textual import, cast it to U-byte array, and then you can do bit twiddling. You can parse any binary or textual format you want to parse. And you can transform it into everything you want to transform it into. For example, invalid decode, which includes inline assembly. So you could write an operating system in JavaScript and have your JavaScript to decompiler compile it. Of course, your JavaScript would need to have some inline assembly support, but actually with that you could write a complete operating system in JavaScript and have D make it magically work. And I would think, yeah, you can do anything. The world is your compile time oyster.
I've got one slightly less ambitious goal. I'd like to be able to raise a number to the power of another number in Ctfa. Yeah.
Well,
we can do that, and then we can move on to the operating system.
Oh, there was something I wanted to say about lambdas. It would be really great if we would be able to tell, if we had the concept of function identity. Like if we had the concept, we have a function that takes two integers and it does something with it. For example, it multiplies them by 2. I want to be able to compare that function to another function and tell if the control flow between those is the same, and then be able to merge them or whatever. That would be really great, but it's a compiler backend thing. It doesn't really belong here, so I'm finished.
Thank you. So this is the only lightning talk today. And mine was moved yesterday because we ran over time, and actually my talk is the shortest of them all. We've seen a wide interpretation of what a lightning talk actually is. You know, anything ranging from 20 minutes to 40 minutes, 1 hour. So let me talk about a bit of history. GNU Geeks, which is a new project. D is a relatively new project. One thing that excites me about D and also about this conference is the low-level stuff we can do. But what actually initially attracted me to D was Andrei's work on the functional programming side. So it's amazing we have a language where we have 3 paradigms, really, in one. And I don't think there's any language like that. Anyone know this? Anyone use this? 1, 2, oh, see, the old hands. Did you buy one? Yes? In today's terms, in today's money, this would have been something like $1,000, I think. So arguably, we are the first people who sponsored Walter Bribe, and therefore we are also the first sponsors of D. Let's see that. So what is D to me? We've been using D in a project called Sambamba. This is a tool that's being used in sequencing centers around the world now for its performance. There's a scientific publication about it. It was an excellent exercise, and it just convinces more that the higher level paradigms that you have for parallel processing in D are really, really awesome. One thing I did was I added LDC to GNU Geeks. GNU Geeks is the new package manager of the GNU project. Right, so Richard Stallman has a plan, GNU, and he wants to conquer the world, and GNU Geeks is part of that plan, though it's not officially so. And it's written in Lisp, you should know that. LDC is an awesome tool also. It's been said today before, and I think it's a totally convincing compiler. And I'm using this tool now to target GPU programs and the Intel mic on the Oak Ridge National Laboratory computers. Yeah, so this is a big data, terabyte, petabyte data stuff. Anyway, this talk is about GNU Geeks, and I want to quote Joe Armstrong, who is another famous compiler writer. And he wrote an email to me just a month ago and said something like this, and I'm allowed to quote it. Yeah, it's absolutely mad to having specialist package managers per language. Yeah, and why do we create these package managers? And the reason really is that the distributions we have are inadequate. And the other thing is that we have multiple targets. You know, we need to deal with that some way. And being programmers, the first thing we think of is to roll our own, right? So we've seen, and Dub is a great tool, don't get me wrong. I think it's a very useful tool, and we should build on that. But it seems to be really inappropriate that we have so many tools for the same job. And in the early days, we just had DOS 16, DOS 32, Windows 16, Windows 32 as targets. Yeah, we ignored the whole Unix world altogether. But now it's become a lot more messy. So as a programmer, what do you really need? Yeah, so to Andrei's first 5 minutes, we need something that works, right? For D to take liftoff here, we need something that works, and downloading a binary through a shell script is not a great idea. I mean, maybe it's a hack, but to download software from something you cannot trust really, It's a really bad idea. As programmers, we want multiple version support. We want to run multiple versions of the language itself, but also of the underlying libraries. We want multiple targets, including development testing. And I think it's key, and once you get used to this, rolling upgrades are awesome. And then one of my hobbies is reproducible deployment. And the thing is that as a programmer, when I write some software and somebody reports a bug to me, I want him or her to have the exact stack of software running to reproduce the bug. Is it my code or is it something else? I don't know very often. Also, as a scientist, software deployment is where it starts to get reproducible research or reproducible analysis. And ultimately, we want full control of that dependency graph. Now, these are the needs as a programmer. But if you look at large deployments, they have exactly the same needs. Yeah, you can just fill it in. We need something that works. Multiple version support, targets, rolling upgrades, reproducible deployment, and full control of the dependency graph. And the thing is, we have it today. Not all of us are using it, right? But we have it today. It's a solved problem. Then a slight digression. I've got 2 more slides. Why do we have a stable distribution, a testing distribution, an unstable distribution, experimental distribution, a security distribution, and a backport distribution? And I'm sure there are a few more. Right? Why? And it's because there's no other way, to get a handle on dependency, the dependency graph, if you don't do this properly. Have you heard of the reproducibility project by the Debian people? Yeah, so they now have, after years of work, 85% of their software builds reproducibility, built in a reproducible way. Yeah, so it's deterministic. That means 15% is still not reproducible. Take pity on us, yeah, on everyone. So when I bring this topic up, people always go like, oh, we have VMs, we have the other D word. But it actually doesn't solve the problem. And anyone who is seriously into software deployment knows this. So to quote another one of Joe's emails, a package is just a blob with a checksum. All right? So GNU Geeks is really based on that principle. Yeah, when you do something like Geeks package install LDC, it will install it, and it will install it in the store, and the store essentially is isolated by the checksums. Yeah, so J55 is a checksum, then you got the LDC compiler and the bin and LDC2, right? And if you go online in the Geeks package list, you can see that it's actually green, so it's building. Sorry, it's a little bit small. Yeah, so Geeks comes with a build farm. Yeah, as soon as you do a commit of a package, you change something or you change the dependency, it will rebuild the whole dependency graph for that particular package, yeah, and it will say if it's okay or not. So that hash, how is it calculated? It actually is calculated over the inputs, all of the inputs. Yeah? So think functional programming. So when the source code changes of a package, the hash will change. If you change a configuration parameter, if you say, I want to build Apache with SSL or without SSL, the hash value will change. You will get a different Apache. When a dependency changes, if it's another glibc underlying it, if it's another OpenSSL library, if it's another BLAS library, or you're building against Atlas, yeah, again, that hash will change, right? So you will know exactly what software you're using, what graph is underlying it. You can actually plot the graph, and you can reproduce it at any time. So Geeks does not replace DUP, but it can make DUP, I think, simpler already. Reliable, robust, reproducible, especially in a Geeks setting. And Geeks currently targets mostly Linux. There's just a port was made for Windows, and the BSDs are coming up soon. The one thing about GNU projects, is they move slowly, but they move. A GNU is something that moves slowly, apparently, but it moves. It's a good thing. Anyway, so Andreas said something about, that's, if it works once, it should always work. I have actually experience with, for example, the Nokogiri package, gem. I don't know if anybody knows about it, but it's notoriously hard to install. Yeah, and the internet is full of people being frustrated with running Nokogiri, which is an XML parser. Yeah, so we wrote a package in GNU Geeks, and now it's there. It's carved in stone. The whole dependency chain is there. Every time I just run Ruby, or was it Geeks package install Nokogiri, it's there. It's like magic. So the final slide, I think GNU Geeks gets a lot of things right, and we are aiming for great. Every package in there is viewed by many eyes, and we're really making a best effort. Geeks has rolling upgrades, versioning of packages, transactions, so if a package doesn't completely install or a dependency doesn't completely install, you can just roll it back. Think about it. The deployments are immutable. Yeah, they're all read-only. Which means that the question of how you deploy software can actually be forked out to Geeks. You don't have to solve it all, right? Geeks works in any distribution. It's distribution agnostic. Yeah, and it's because the store where everything is installed is separate from user local bin, the whole FSH thing. And soon we will be adding Dub itself, and with that we will create an abstraction which we will call the D build system. We also have the Ruby build system and the Python build system and all that. And we'll have the Emacs D mode in there too. And I hope today or tomorrow also to talk about getting GDC in there, for example. Yeah, so you can just choose one or the other. That's it. Thank you.
Does the standard include the distribution aspect, for example, hacking up pre-built packages into useful small package, like BitTorrent, for example, and load balancing?
Right. You're talking about distribution now of binary packages? So Geeks does supports both binary and source distribution. If the binary package cannot be found, it will automatically build it from source. It's designed as a distributed system for package distribution. The GNU people are very wary about privacy, about how you deal with security, right? And they have created a system here. I think they even want to involve Darknet somehow, but I think that's a Google Summer Code project. But it's almost trivial to set up your own Geeks caching binary distribution server.
Could you expand a bit more how Dub is actually plugged into the system? Because as far as I understand, GUIX packages are supposed to be definitely defined by their dependencies. And with Dub, you kind of, at least right now, forced to download sources. So how does it fit together? The fact that Dub depends on the registry and whatever is defined by external repository and reproducible builds.
Right. So I created the Ruby build system. So Ruby has Ruby gems, which is similar to Dub in many ways. And what we actually use is a Ruby path. Yeah. So the search path. You put the search path for Geeks first. Yeah. So if a certain version of a package is already in the Geeks search path, it will find it. Yeah. So Nokogiri it will find in Geeks. But if you have a gem which is not in Geeks already, you can just use the gem install path and it will automatically build on top.
when you decided on a package manager for this entire enterprise, I assume you evaluated some. I would like to ask what the main reasons were for GUIs and not Nix, because they're essentially the same,
yes.
except Nix is already distributed with NixOS and pretty much really tested.
Sorry, what is the question?
What your main reasons were for GUIs, to select GUIs as your package manager.
Right. So Geeks a few years ago forked from Nix. Yeah, so NixOS has been going for, well, I think 12 years now. And I know the Nix author also very well. So Nix is awesome. I mean, a lot of the infrastructure and all the choices that we are benefiting from today, they come from Nix. But one problem with Nix that I always had was its DSL. Yeah, so Nix created its own domain-specific language for packaging. And my brain is too small to really grasp it. I tried. I built a lot of packages also in Nix. Yeah, so then when Ludovic created a front end in Guile in Lisp, and he showed us what it looked like, I was just immediately sold. And so essentially they are very similar projects. The GNU Geeks has a different front end, so the packages are written in a Lisp, which you should view as a type of JSON or YAML. The other difference is that Geeks is drifting away from Nix in some ways, and one of them is that it's totally focused on free software, right? So the whole software stack that is in GNU Geeks, the official distribution, is all free software. But it's trivially easy to add your own Git repositories, which you can sort of merge into the Geeks one without mixing it with the main distribution. Yeah, so I run a web service with an incredibly complicated dependency graph, and most of the software is open source in there, but I don't have to have everything in Geeks to deploy that system. I still use the whole concept. It's easily to do. You can easily do it. And because you can easily build caching servers, it's also trivially easy to deploy.
Hi. Yeah, I think the whole idea of repeatable builds is just fantastic. But one question is, if the example that you gave was maybe if you change whether dependency is compiled with, say, SSL or not SSL. It's an arbitrary example, but the question is, does this not sort of create a sort of Cartesian explosion of things that you have to rebuild depending on what settings your various dependencies were compiled with? And is that addressed at all, or it sounds like it's going to create just a almost infinite graph of combinations that have to be built?
Yeah, so SSL is a pretty good example, of course. And until quite recently, you had, if deep in the dependency graph, like an libSSL was changed, if the source code changed for whatever reason, it would trigger a set of rebuilds, in the full tree. And there are over 3,000 packages now in Geeks. I think there's 15,000 packages in Nix at the moment. Yeah, so that would put an overload on everyone. Yeah, trying to reinstall software. But we now have a new technique. It's called grafting. Yeah, so in the post process, only those packages change that need to be changed, and they can be merged again. So they have found a lean solution for this.
Good stuff. Okay, thanks.
Do we have a final question?
Well, one comment then, if I have the opportunity. It's trivially easy, since all the Geeks packages are in one location and all the dependencies are known, you can quite easily migrate a software project with its dependencies to a different machine. It's basically a copy. All right, thank you.